Hello everyone, my name is Priya Singh Rangey and I am an assistant professor at the LJ Institute of Physiotherapy. The topic of the day is electromagnetic spectrum. Today we'll be discussing about what is electromagnetic radiation, what is an electromagnetic spectrum, and what are the different waves that are included in the electromagnetic spectrum. What is electromagnetic radiation? It is a form of a wave consisting of regular sinusoidal electric and magnetic fields that are lying at right angle to each other. As we can see in the diagram, the red colored waves are the electric field. The blue colored waves are the magnetic field. Both the electric and magnetic fields are lying at right angles to each other, and the purple line represents the line of propagation. It is the direction in which the electromagnetic radiation is going to propagate. The electromagnetic spectrum is the characteristic distribution of electromagnetic radiations emitted or absorbed by any object. The nature of electromagnetic radiation can be described based on the wavelength of the radiation, the intensity of the radiation, the frequency of the radiation, and the velocity of the radiation. As we all know, the velocity of all the radiations is the same, which is 3 multiplied by 10 raised to 8 meter per second. The velocity for all radiation remains the same, but the wavelength, the intensity, that is the energy that they carry, and the frequency are variable. What is wavelength? Wavelength is the amplitude of the wave, and it can be measured in micrometers, millimeters, nanometers, meters, any units of the distance variable. The frequency of any wave is the number of waves that are passing any one particular point in 1 second or unit time. Frequency is usually measured in seconds. The unit for frequency is hertz. Intensity is the energy that is carried by any particular wave. The higher the energy of any wave, the more destruction it causes. Hence, we can say that the nature of any particular radiation is based on the wavelength of it, its intensity, its frequency, and its velocity. All the electromagnetic radiations possess some physical properties like reflection, absorption, penetration, or scattering. The discussion about these physical properties cannot be done at this point and will be continued later on. Now, moving on to the electromagnetic spectrum. There are 7 types of electromagnetic radiations that are comprised in the electromagnetic spectrum. As you can see in the diagram, we have radio waves and we have microwaves. These are the high wavelength and low frequency radiations. We have visible, infrared, and ultraviolet radiations which lie in the center of the electromagnetic spectrum, and we have X-rays and gamma rays which lie on the right side of the spectrum. When we move from the left towards the right side, there is an increase in the frequency of the waves and a decrease in the wavelength of the waves. So, the waves that lie on the left side are higher in wavelength and lower in frequency, whereas those which lie on the right side of the spectrum are higher in frequency and lower in wavelength. Wavelength and frequency are always inversely proportional to each other. So, whenever there is an increase in wavelength, there is a consequent decrease in the frequency and vice versa. Now, moving on to the different types of electromagnetic radiations that are included in the spectrum. Starting with radio waves. Radio waves are the longest wavelength waves. They have the lowest frequency, hence they have the lowest energy. They are usually used in communication, radio broadcasting, satellite dishes, televisions, phones, etc. But prolonged exposure of radio waves can cause cancer. Second is the microwaves. These are also radio waves with very high frequency, that is comparatively higher frequency. They are used in cooking, in microwave ovens. They are used in cell phones and for radar images. Next, moving on to the infrared waves. The infrared waves are produced from any object that is hot, like the sun, any object that we are heating, like radiators, etc. Infrared waves are usually felt as heat energy or warmth. All warm objects can produce infrared radiations, like we already discussed. Infrared radiations have slightly lower energy than visible light. They can raise the thermal energy of any object. and we can use a thermogram in order to know what the intensity of the infrared radiations is, or what the measures are of the different radiations. There are three types of infrared radiations based on their wavelengths. You have infrared radiations of the A type, which is 750 nanometers to 1400 nanometers on the wavelength spectrum. You have IRB, which is 1400 to 3000 nanometers, and IRC, which is 3000 to 1 lakh nanometers. You have another classification for infrared radiation, which classifies infrared into near IR and far IR. Near IR is 750 to 1500 nanometers, and far IR is 1500 to 15,000 nanometers. Next, moving on to visible light. Visible light is the only part of the electromagnetic spectrum that is visible to the human. The visible light, when we can see, it consists of 7 different colors, which are violet, indigo, blue, green, yellow, orange and red. As an acronym, we can use VIBGYOR. When we say VIBGYOR, moving from V, that is for violet, to red, are the colors are in order of decreasing frequency and increasing wavelength. Hence we can say that violet radiation has higher frequency than indigo or blue radiations. Ultraviolet radiations are invisible sunlight. They are helpful in producing vitamin D, and we will require a sunscreen in order to protect our skin against ultraviolet radiations. Sunglasses are used in order to protect the eyes against ultraviolet radiations. UV radiations can be used for killing bacteria, reducing infections, reducing inflammation, etc. UV radiations possess little higher energy than visible light. There are 3 different types of UV radiations: UVA, UVB and UVC. UVA radiations cause tanning and wrinkling, and they lie in the spectrum of 315 to 400 nanometers. UVB causes sunburns and cancer, and it lies in the spectrum of 280 to 315 nanometers. UVC is the most harmful, and it can cause sterilization because it can be used for killing different microorganisms. It lies in the spectrum of less than 280 nanometers. Next is X-rays, which have the second highest frequency, and we can say that they have high energy, but the wavelength is quite low. X-rays are usually used in hospitals for diagnostic purposes. They are also used in airports for scanning and security reasons. X-rays are given off by stars, and they can also cause cancer. X-rays possess higher energy than ultraviolet radiations, and they can penetrate soft tissues but not bones, and hence we use X-rays in order to develop radiographs, which can be used for diagnostic purposes. The last radiations on the electromagnetic spectrum are the gamma rays. These gamma rays possess the shortest wavelength, but they have the highest frequency and hence possessing the most energy. Nuclear explosions that occur within stars like the sun produce gamma radiations. Gamma radiations, since they are possessing the most energy, are very harmful to the human beings. They have the highest energy, and they are usually emitted by radioactive atoms as well. Gamma radiations can be used to kill cancerous cells. To summarize, we can say that the electromagnetic spectrum possesses a broad range of different wavelengths and frequencies. It goes from the radio waves, the microwaves, to the infrared, visible, ultraviolet, and then moving on to the X-rays and gamma rays. All the different types of radiations possess different properties, possess different natures, and based on their nature, they can be used for different purposes. Thank you.